Hello, everyone. We would like to present our team, GoGloves, as part of the MSEM department. I would also like to introduce our team, which consists of myself, Vahe Hamdillian, as a General Manager and VP of Planning and Operations.
Christian Miranda, Project Manager and Director of Procurement.
Harnik Dogra, Vice President of Manufacturing and Production Control.
Daniela Barajas, Director of Quality Control and Quality Assurance.
We would like to present our GoGloves autonomous glove dispensing unit, which consists of add-on features such as the hand sanitizer and infrared thermometer, which is all completely touchless with the utilization of sensors. Our main design objectives were to offer a sterile method to obtain gloves in a quick and easy manner. Our mission statement is to reduce contact contamination and by spreading awareness on proper public hygiene practices. Especially with the COVID-19 still looming around, we want to help fight this pandemic together. Our design takes an example of a traditional vending machine, but dispenses vertically instead of horizontally with the help of gravity. We have created a Gantt chart which lists all the major tasks assigned to each appropriate member throughout the 16-week period. It is color-coded, which is categorized by green being the planning stage of the project, blue being the design and manufacturing stage, and red signifying the final stages and the touch-ups towards the end. So we had a clear goal in mind from the beginning of August 2020 last semester, and we needed to set a process model of the main tasks required to complete our project. We needed to identify the problem with the standard glove obtaining methods as of today. So we wanted to address the reduction of contact contamination and safety and health issues. So we began doing preliminary research early on at different ways to implement safe, healthy practices and introduce proper public hygiene to the community. We then made various changes along the semester and updated our product design to offer more versatility within our unit. And then dedicated March and April of this year to manufacture and produce our final end product, and also tested our unit for its functionality to be able to present for the showcase.
We would also like to thank our sponsorship locally here at CPI, Chatsworth Products. Their capabilities of manufacturing, including laser, sheet metal laser, 100-ton press brake, MIG and TIG welding capabilities, and our powder coating capabilities helped us complete this project. They are here local, but however, they have 3 plants nationwide, and they're internationally known. Their main business is data infrastructure, where they make cable managers and cabinets for data centers. And we would like to thank them for sponsoring our project and getting it made for us. Starting with how the manufacturing process came about. So we have our main enclosure from the top, and the main enclosure was made out of mostly 14-gauge sheet metal. And this included shearing operations, laser cutting operation for the sheet metal, and a bending operation afterwards on the press brake. After the parts were bent, they were led into welding, and then we MIG welded them. And afterwards, they were put on the powder coating line, where they went through a wash, and then they had powder applied to them with an electromagnetic static powder. And then they were went through a cure oven, and then they went to assembly. For our process in our manufacturing field, if we do go into a new facility and better, we would have an inspection where if during assembly it would fail, we would do rework, and then we would do inspection again. Depending on that, if it was fail or pass, we would either scrap it, because if we do too much rework, then it might destroy the structural integrity of the actual part. So we kept that in mind throughout the process. The main leg that actually holds the whole enclosure structurally needed to be solid. So we used a thicker gauge tubing, which was also just brought as a regular steel tube, and then we put it into a laser cutting tube cutter, and then they were welded and powder coated also along with the base. The base itself is a heavy 10 gauge that is welded together to combine so it doesn't tip over or fall on each side, depending if somebody pushes it or there's an earthquake. And then all this is led into assembly, packaged, and shipped out. So the functionality of the machine, it's a very simple setup with how the electronics work. Specifically, starting from the right side, we'll go to the left. So starting from the right side, we have 110 AC voltage going into a power supply. The power supply then converts that voltage into 12 volts DC, which goes into a relay. We do not have a microcontroller like Arduino attached to this at this point. However, continuing on with this project, if we do after school, we could look into programming it. So this is it's a basic relay setup where you just have a switch with a proximity sensor, and it's normally open, and then no, it's actually normally closed. And then when you have a proximity sensor, it switches it up to open to allow the current to go through. This leads into a 12-volt motor, and then the motor is attached to a spring. And as the motors and the springs rotate, glove gets dispensed down. So for our end product, we kept in mind the touchless, the glove dispensing. We wanted everything to be touchless, as Vahe mentioned before. We wanted to fight COVID. So we have a touchless hand sanitizer on the right side too, and the thermometer on the top that reads your temperature as you walk up. And also, if you can notice in the picture, there's a blue light. That's a continuously running UV light, which is killing the germs and sterilizing it as being input. We wanted to accommodate a loading and unloading person, and if they're sick or something's wrong, the gloves will all be sterilized and hygienic.
So our main objective is to reduce cross-contact contamination. By doing that, we want to prevent the spread of viruses and bacteria that are in most of the surfaces. As humans, we tend to use our hands for pretty much everything from the beginning of the day to the end of the night. We touch our phones, door handles, doorknobs, keypads, keyboards. And for that reason, it made it pretty easy to have an open market where we could include our enclosures too. But we specifically want to focus on the healthcare industry because they promote proper hygiene. It's also a place where it has to be free to the food and beverage industry as a barrier between the employees and the customers. And finally, to the everyday user, to the consumers, so that they could use it in any public place, such as grocery stores, parks, pretty much anywhere, gas stations, anywhere where they could encounter cross-contact contamination. Next slide, please. Yeah. So one of the big first stages that we did for our project was to figure out the competition. Who's out there, who's doing it right, who's doing it wrong. This is basically to find that price point so that we know the budget that we have to work with. Also, so that we could figure out what's going to be the price tag that we want to put for our enclosures. During this stage, we also compare what differentiates each company from each other. That way we can incorporate some of their benefits to our design or also innovate on whatever needs to be improved on. But most importantly, it was to figure out a benchmark company. And we chose GoGlove as our benchmark company for two reasons. One of them is versatility, that they have both in the industry and in the product, and efficiency. So our gloves are pre-packaged, so a pair of gloves. That way we reduce the number of the time it takes for you to go into a box of, let's say, 100 or 500 glove count and obtain a pair of gloves. It also stops that cross-contact contamination that may happen there with you trying to dig in and separate all those gloves. And also with the versatility we offer is a variety of different industries that we can market to, as well as add-ons that we could provide to our main unit.
So our bill of material consists of many parts that help our project come to life. The bill of material that you're seeing right now is for our basic unit. Our basic model, which has a cost of $542, with the total cost of the whole unit being $925 with 75 cents. Once we have mass produced and wholesale the materials, we plan to bring down the cost to bring the cost down 50 to 55%. in order to have a competitive pricing and have appropriate profit margins. So this second bill of material is for the component that has the attachments, which include the thermometer and the hand sanitizer. So the total cost of the materials for this one was $654 with 16 cents. And with the total cost of the whole unit being $1,062 with 16 cents. Again, like with the other one, we plan to mass produce and bring the cost down.
So we have set different revenue streams to keep cash flowing into the company. We divided into our main sales of the GoGlove dispenser. We also divided it into our online add-on sales, which consist of glove package refills, along with the thermometer and hand sanitizer separately. And in the future, we would like to produce and pre-package our own gloves to have complete control of the supply chain.
So our design consists of modular units. We decided to go with this because it's easy to mix and match enclosures and to also fit any custom space. Some of the benefits that come with this is that the customers could customize the unit to however they like, if they want one enclosure or multiple enclosures. It's also faster to release to the market. It's cost efficient. We don't have to go through new product development to redesign the backplate or the doors or the chutes. It's also just because of sustainability, we are able to reuse some of the components that other enclosures have. So about 24 billion pounds of plastic enter the oceans every year. So we want to be part of the solution and not the problem. For that, we decided to partner with GoGloves. GoGloves are biodegradable and compostable gloves. They're individually prepackaged, so that's something that we wanted to focus on. They're made with plant-based materials. And for the future, we do plan on offering nitrile gloves also prepackaged and also giving the customers customizable options, such as customizing the color to however they want or incorporating their company logos.
Pardon me, but your time is up.
Okay. Is there, okay. We also had a demonstration video as well, but
Okay. We need to move. Okay. Although we did start a couple of minutes late, but we do need to move on to questions and answers.
okay.
Okay. So I'd like to open the floor to 3 minutes of questions and answers.
How long is the video?
It's a minute and a half, exactly.
Can I see 30 seconds?
Of course.
I'm okay with watching it too, to use our time if you want to.
Okay, good.
So this is our glove dispensing machine. It's a single slot glove dispenser with the touchless hand sanitizing dispenser and infrared thermometer. As the user approaches, sorry, maybe if I can open it up in a different tab.
Can you drop the YouTube link in the chat?
Yeah, of course. Of course.
The current temperature is 97.9 Fahrenheit degree.
So yeah, it's also voice activated, the thermometer along with the display of the temperature and the hand sanitizer unit on the side. So once the user waves their hand down the sensor, the chute, the glove dispenses down the angled chute. This makes it a quick and easy autonomous way to obtain gloves. And it's also tamper proof. So the only person that has access to it is the maintenance key holder, which is able to load up all the gloves in there. So that's the spring that we used to adapt to fit onto the adapter. which then fits on, connects to the motor shaft, which rotates once the sensor is activated by the user.
Excellent.
Perfect.
How much time, Dr. Connor?
One more minute. We need to switch over by 1:35, but
Okay.
if there's any questions anyone has.
I think it looks like a really straightforward and robust design, and I appreciate that you considered the waste part of the equation because we all have seen so much waste with what's happening in COVID response, right? So kudos to you all for worrying about that.
What was it like to work as a team?
It was amazing. Honestly, this was the greatest group of people I've ever worked with. Everyone was always on task. There was never any issues with any of the team members. Everyone was always concurrently working together, trying to finish the project with one end goal in mind.
Excellent.
This is Cash. If the glove is stuck in the machine, is there any precautions to actually be able to remove it, or the machine stop keep working and it doesn't figure out, you know, the fault in the system?
So because we have created an angle chute, that way, in case the glove does get stuck by any chance, the metal spring is able to bring that bring the glove down through the angle chute. So there's no possible way. We tested it as well to make sure that everything falls down correctly.
And also it's angled in a way to where gravity will allow it to just dispense perfectly.
Thank you.
Okay, well, that's all the time that we have for questions right now. Thank you very much for your presentation.
Thank you, everyone.
Thank you.
Thank you.